Okay, this is for Lab 2, Population Ecology. First, we're going to take our beans. I'm gonna open them. And we're gonna take this shoebox. We're gonna take 4 large handfuls of these. 1, 2, 3, 4. Take 4 of them. We're not counting them. We're gonna make an estimate for how many we have. I'm gonna say we have 70. So that's my estimate. Okay. Now we are going to pick up a handful and we're gonna count them. So, and as we count them, we're gonna mark them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18, and that is going to be our big M. So our first trapping sample. Okay. Now we're going to release them back into the population. Okay, now we're gonna shake our shoebox. Okay, and we're gonna grab another handful. Now we're gonna see how many we pulled out in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our small n is equal to 20. And that is, now how many of these beans are in your second trapping sample that were already marked? We have 2 that were already marked. So that's our small m is 2. Perfect. And now we're going to use the equation above to calculate the big N. So that means we are going to have 18, 20 over 2. So here's our little equation right there. So we're going to use that, and we're going to multiply 18 by 20, 18, 20. That is 360. 360 divided by 2. Divided by 2. 180. So our big N is equal to 180. Count the actual number of beans or whatever in your box. Okay. So we know that we have 20 here. Let's count all of these. 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94. We were very wrong in our guess. 96, 98, 100, 102, 104, 106, 108, 110, 112, 114, 116, 118, 120, 122. This is a lot of beans. 124, 126, 128, 130, 132, 134, 136, 138, 140, 142, 144, 146, 148, 150, 152, 154, 156, 158, 160, 162, 164, 166, 168, 170, 172, 174, 176, 178, 180, 182, 184, 186, 188, 190, 192, 194, 196, 198, 200. Oops. Okay, 200, 202, 204, 206, 208, 210, 212, 214, 216, 218, 220, 222, 224, 226, 228, 230, 232, 234, 236, 238, 240, 242, 244, 246, 248, 250, 252, 54, 56, 58, 60, 62, 64, 66. So we had 266 and we guessed 70. That's rough. That's the actual number of beans. Was my estimate using the ratio closer than my initial guess? My estimate was 1,000% closer than what it was with my initial guess, because my estimate was 180 and my guess was 70. And how did I increase the accuracy of my estimate? So I took the basic population, made a guess, and then took a sample size, and by using that sample size and marking them, I put them back into that population, and I pulled out another sample. And then out of that sample, I counted to see how many were already marked and how many I already had. And by using that, I did a little equation where I calculated the population estimate by taking my first trapping sample, my second second trapping sample, and multiplied them, and then divided it by the amount that were actually marked. Perfect. And then, what species of animal would that work well for? What species of animal would this technique not work for? Why? I think this would work well for species of animals that don't necessarily that live longer lives. So, like, for example, this would work for deer, whereas I don't think this would work for flies because flies die so quickly. Can I think of a better way to estimate the number of beans in the box? No, I don't really think there's a better way than calculating it to estimate it. So, yeah.